Good afternoon. It's March the 1st, Friday, 3:45 p.m. This is Joshua Taylor coming to you from here in Hope, British Columbia on the Joe Pipe technology. And God gave me this technology to provide the heat and power systems for the places of refuge. And I'd like to see this to be developed actually for these micro camps using retrofitted campers and RVs. And like the price of building now is just outrageous. You can't even afford to build a shack, but I know that you can take an older camper and RV, and you can insulate it using aircrete or whatever to make it at least R20 in the walls, much better than the new campers that you buy. But anyway, I'm going to show you the Joe pipe. This is around a 20-inch piece, 2-inch piece, schedule 80, and in the past I've been able to turn these things absolutely red hot. You can't touch them, even with leather gloves. Even with leather gloves, the heat goes right through and it burns up your gloves. But anyway, I want to share what I'm planning to do in the next week. It's actually going to be in two parts. The first part is to get my system back up and running. It's been at least several years that I've been able to play with it, or I've been able to set it up. So I repainted all my pipes, and hoping to be set up in a couple days. I need to build a refractory out of fire brick, and I like to start experimenting with what's called starlight. So this part of the pipe represents about 1,000 to 1,100 degrees. The heat coming out of the end is about 2,100 degrees. So you have two sources of heat. If you actually insulate in the heat, you can take the 1,100 degrees and add it to the 2,100 for about 3,000 degrees. I've measured internal temperatures in the past using a laser gauge up to 2,600 degrees, and it works better in the summer than it does in the winter, probably because of the moisture that's in the air is converted into hydrogen or monatomic hydrogen to give you the to beef it up. But anyway, starlight is something that I just recently discovered, and what I would like to do is to make some starlight and wrap it around this pipe. I might put two pipes together and put the starlight in between the pipes. I like to be able to burn the fire inside of a pipe made of starlight with no by itself, right? But you still probably will need an outer pipe to keep it from falling apart. And so I'm hoping to be able to raise the temperature to where I can easily melt copper, melt glass to bring the temperatures up. I'm hoping for a minimum of 2,500 degrees. And the CO2 that comes out, actually, I'm going to use that to take wood and take bread and to make carbon foam out of it. And what I would like to do is be able to make a mold out of plaster, a mold with a lid on it. I'd like to take the starlight and pack it in there, something about maybe 3/8 or ½ inch thick, fill it up with starlight and bake it, and bake it using the superheated CO2 from the Joe pipe. And there's other things you can do. I'm hoping to be able to crush down the carbon foam, if I can actually get to that point, to replicate it and to maybe mix white glue with it, same as you do with starlight, and to paint it on a piece of aluminum to see if it's going to withstand, see what temperatures it can withstand, maybe put multiple layers on it to see if it beefs it up. But the primary reason for that is to create a thermal heat shield that's going to be able to repel the heat from the sun, to create a thermal shield that's going to block out the UV rays, the transferring of thermal energy into the unit. And also in the wintertime, it should work in the reverse to keep heat within. And there's other experiments where I would like to make a little box out of maybe take a metal container. This is plastic. We'll take a metal container and wrap Starlight around it, and with the lid on, and see if the inside, what the inside temperatures would be, and to maybe where the inside temperatures could actually be develop some type of refrigeration. So that, you know, I would have to kind of mess with that, but it's kind of going off my gut. As far as Starlight is concerned, this would be probably revolutionary. Nobody else is actually, you know, they're kind of following the mainstream. There's lots of people that like to replicate work that other people are doing, but I like to be on the edge of discovery and just allow the Holy Spirit to guide me in what to do. So I like to take Starlight, make it and bake it to fully crystallize it. I like to take, be able to make carbon foam, maybe out of 4x4 blocks, maybe cut off some slices to see if it's going to caramelize. Take it, crush it down, and put it into a blender to make a paste. Maybe use different binders, maybe mix in a little bit of starch in it, like you do with Starlight. Starch is the primary ingredient, and so when heat's actually applied to it, the starch caramelizes. It turns into fire foam, into carbon, and so I think it's going to prove to be very interesting. But to be able to make the bake the Starlight and to make the carbon foam, I'm going to have to make a refractory out of K2300 fire brick. I have a white ceramic roll that I can lay down, build the kiln on top, wrap it up, and just allow enough leakage in the bricks where when the CO2 is put into the kiln, that any excess is going to come out. The main purpose is to be able to displace the air. Normally you would use some form of gas inside, inert gas, argon or something like that, to displace it. So it'd be interesting to see what CO2 will do to replace it. Maybe it won't work, maybe it will work, maybe I'm onto something, but you know, you have to try. And when Maurice Ward was given when he actually developed Starlight back in the early 1990s, NASA tested it. They actually ended up stealing his work. It went silent, but his work is actually being used on the spacecraft and all that for thermal shielding. And when NASA tested it with a nuclear blast, it was able to withstand over 10,000 degrees centigrade. And so the second aspect of testing would be to make I'm going to try to make a pipe out of Starlight by itself, and also like an inside wrap. And I'm not sure how Starlight's going to hold together if I bake it, but I like to be able to use it as an individual piece, no metal involved, to be able to hold in the heat. And so there should be hardly any measurable temperatures on the outside of the Starlight. It should retain the ambient temperatures. But this one test I did years ago it was up north in not in Fort St. John. It was on a Russian-German community. Summer, all the kids were around, and I was testing a piece of Inconel. And so I had a secondary air set up with my supply air was a vacuum. So when I cranked up the air, when I accelerated the implosion process, the ink canal went into an implosion into a plasma anomaly, and it sheared it off. And so you could beef up the uh, the combustion process by ramping it up with air, or adding some kind of oxidant, or turning up the fan or whatever. But like to try this by super insulating in the heat to see if the propane and the air will actually go into a quantum reaction. So I've seen many anomalies over the years where normal petroleum fuels, especially water gas, will go into a plasma compression, where it actually goes from laminar flow into a spin. And it's taken me a lot of 15 years to understand this, to where it goes into like a tornado, but all the force is being pulled in toward the center because of the vacuum that's in the eye of the tornado, right? So as the energy is spinning down toward the point, it's causing the density of the matter to be compressed, to increase, just like when you like in a black hole or in a star that's in the process of collapse. The energy goes in and increases the gravity, and the gravity increases the density, where the matter becomes very dense. So when you squeeze matter like that, it's going to change the properties. So what happens when the energy is spinning down and being compressed, it reaches a certain point where it can no longer handle the excess energy that's being developed in the quantum state, and it releases it as some form of plasma anomaly. I've seen well over a dozen. So I'd like to take these steps to first set up my apparatus again, to build a kiln, to try to make carbon foam and test starlight, and then set up, also try to make a thermal paste as a thermal insulator for RVs and campers, and then go into the second phase. I would have to develop a dual fuel system in the back, so I can inject propane and water gas and maybe oxygen and MAP gas and things like that, and maybe with the starlight pipe, if I can get to that point, to see if it's going to push it into the quantum anomaly. So I know it's possible from results over the years that you can take normal fuels, that you can increase the velocity of the fuel. The fuel has velocity. A normal propane torch, for example, has about 3 meters per second. A jet has about 20 meters per second. Plasma has about 40 or 20,000 feet per second, and plasma actually is in the range of 40,000 feet per second. So the speed or the velocity of the flame is directly proportional to the increase in the heat being generated. So the faster you get the flame to burn, the more energy that's released, not touching the fuel. You're just getting a better reaction of matter into energy. And so what they teach you in school, universities and all that, have already broken those parameters. And I know it's possible to take gasoline or diesel and to get a tenfold increase in the BTU output and the thermal energy output, because it's all a matter about being able to crack the full carbon potential that's in the fuel. And when you do that, you get zero emissions. And so if I can actually get to the point where I'm able to replicate a plasma anomaly repeatedly in excess of 5,000 degrees, maybe 10,000 degrees, it opens up the doors to do anything that you want. And the primary application would be to use plasma where your fuel is broken down into a plasma to generate an unlimited heat source to gasify any and all known organic waste. And once you can do that, either through gasification or pyrolysis. You can make your fuels, compress your, make your diesels and your gases and things like that. And then you can take that and you can further refine it through what's called the GEET technology, GEET, developed by Paul Pantone. He was put in jail for trying to get this to the world, and he died several years ago. I'd like to be able to merge the Joe Pipe technology with the GEET technology to develop a super hybrid system where it's independent of having to use an engine to supply the primary heat source and the vacuum. So it's possible, if you got a plasma flame, you can generate unlimited supplies of fuel, and or you can actually reprocess it further to where you can get many more times the yield out of the fuel that you're producing. So I'm talking about, if you got 1 gallon of stock fuel, whether it be gasoline or diesel or crude oil, you can get 10 times or more energy output. And the times that we're coming into, if you don't have a system set up like this, how are you going to be able to live without having to go to the store, right? We're going to have to get out of the system and have develop technologies, God-given technologies that's going to free us from having to take the mark of the beast. And that's what's coming. We have maybe 3 years before we see the Russian and Chinese invasion coming into North America. America is going to go into 7 years of occupation by foreign troops, and toward the end, just before Jesus comes, God's going to raise up a people that's going to push the Russian and Chinese forces into the sea. But between now and then, we need to prepare. Preparation means faith in action. Noah believed God about the judgment that's coming, and he was given a plan. And because of his obedience, he implemented that plan for the saving of his family. And so do we in these times. So I'm just going to leave it here about the Joe Pipe technology as probably the best system for developing on-demand hot water systems. A friend of mine 5 years ago, I ran with the Joe Pipe technology, ran back and forth to the Victoria University on Vancouver Island, and he was given a grant where he was able to develop it and quantify it, and he's proven it by the numbers that the Joe Pipe technology is 300% more effective than the best heating systems in the world as far as hot water heating. And then shortly after that, a year or so after that, he was just given a European patent. So I missed the boat on that one. But what the Lord has given me is not for me. It's for those of you who believe that want to take the steps to prepare to go off grid, because we're going to have to go off grid if we're going to have to survive these times ahead. The cities will one day, the grid will go down, and be destroyed, and those that live in the cities will become trapped in destruction. So we need to prepare while we can, out of faith and out of love. And any help that you could send me financially, I haven't asked for help in the past, but it's encouraging, right? It's encouraging that some of you out there might believe in the work that God has put in my heart to do for the preservation of His people. This is Joshua Taylor coming to you from here in Hope, British Columbia, Canada.